This is the screencast for section 3.1, example 7. We're going to model San Jose's population. The problem says using the data in table 3.5, that's over here, and assuming the growth is exponential. That actually gives us a clue as to what form our equation will take. So since our growth is exponential, we're going to be using y equals a times b to the x, exponential growth. The question is, when will the population of San Jose surpass 1 million people, persons, whatever? Instead of using the year 1990, I'm going to use the year 0, and then instead of using the year 2000, I'm going to use the year 10. So I can see that the population is growing, and the problem tells me that it's growing exponentially, not linearly, but exponentially, not logistically either, as we were talking about in the last example. So now I need to set up an exponential growth equation to model these two population data points. Alright, so first I have my initial value 0, 782,248. So I'm going to plug in 0 for x and the big number for y. So 782,248 equals a times b to the 0. So at year 0, here was the population. B to the 0 is 1, so I just get that a equals 782,248. So far, I've got y equals my a value, 782,248 times b to the x. Alright, so now I need to use my other data point to be able to solve for b. So I'm going to plug in 895,193 for y. And then the x value that belongs with that is 10. Got to divide both sides by 782,248. I'm not going to actually calculate that fraction yet. I'm going to wait till the end so that my answer is more accurate. The more times I round, the less accurate my answer will be. And now I have to take the 10th root of both sides to be able to get b by itself. So b is the 10th root of 895,193 over 782,248. So 895,193, 782,248. Okay, nope, no problem. So y equals my a value, 782,248 times the 10th root of that same, 895,193 over 782,248 to the x. That is my exponential function. Here's my initial value times, here's my base, and then to the x power, exponential growth. The question asks, when will the population of San Jose surpass 1 million people? So I have to set this equal to 1 million and find out when at what year it will get to 1 million people and therefore surpass it. So I'm going to put in y1, 1 million. And then in y2, the 10th root of this mess is going to be complicated. So I'm actually going to go to my main screen. I'm going to put in the number 10. And then I'm going to go to Math. And that number 5 has a little x in the root. So if I hit 5, the x takes on the value of number 10. So now I have the 10th root. And now I can type in my fraction. So 895,193 divided by, let's see, that would be 782,248. Hit enter. Now it's got this value. That value is greater than 1, which is good because I know that this is an exponential growth function, so that value should be greater than 1. I'm going to store that value, so hit stow, as the letter B, alpha B. Since that's my B value, I may as well store it as B. So now if I go to back to my y equals, I can put in 782,248 times actually alpha b to the x, because your calculator has memorized alpha b as that value. Now I got to set my window. I'm thinking that for my, well, my y values, they have to go up past 1 million because y1 is at 1 million. So I'm going to try 1.5 million. My x values, let's see. Well, this is exponential growth. So it's going to grow faster and faster as we go on in time. So if 10 years it grew 100,000, I'm thinking another 10 years will definitely get me above 1 million. It might only take about 5 years because we said it was growing faster and faster as we go. So I'm going to change my my x-min to maybe -5, just because I don't need to see negative years. X-max, I'm going to go to 20, probably only need 15. X scales, 1, fine, no problem. Y-min, it doesn't matter, I don't need to see negative population values. Y-max, 1.5 million. Let's see what that looks like. I can kind of see the intersection, but it's not growing as fast as I thought it was. I mean, I guess that B value is only a little bit above 1, so it's not going to grow very fast. So I'm going to change my X max to maybe 30. That's better. Now I can see that intersection very clearly. So second calc intersect, enter, enter, enter. Looks like it's going to take about 18.21 years. The question says, when will the population of San Jose surpass 1 million people? So 18.21 years would bring us to about, let's see, that'd be 2008. The now try problem for example 7 is number 51. We're going to do the same exact thing. We're just using a different city, some different data. Using the data table, or excuse me, data in table 3.7 and assuming the growth is exponential. So again, we've got our exponential growth, y equals a times b to the x. When would the population of Austin surpass 800,000 people? Well, this table's got more data on it. I'm looking at actually Columbus, Ohio data, which the problem said nothing about, so we don't need to worry about those. Now we've got in 1990 Austin's population and then in 2000 Austin's population. So I'm going to call 1990 year 0 again, as well as 2000 I'm going to call year 10, and I'm going to set up my exponential growth equation, same as I did before. Plugging in the initial value, 0 and 465,622. So I found out that my A value, to no surprise, was 465,622. Now I'm going to plug in the other point. After 10 years, the population was 656,562 to find the B value. So now I'm going to work on, I've got my equation for exponential growth, 465,622 times the 10th root of 656,562 over 465,622 to the x. So now I got to work on getting that into my y equals and finding out when Austin's population will surpass 800,000. I'm going to store my b value in my main screen again, as well as put in y1, 800,000, and then y2, my exponential growth function that I found. This time for my window, my x max, let's see, 30 years is probably a good guess, but it's probably going to take a lot longer than that, just because I'm not really close to, well, I'm kind of close to 800,000. All right, we'll try 30 years. We'll see. And then my y max, I'm only looking for the population of 800,000, so I'm going to set my y max to 1 million this time instead of 1.5 million. And we'll see what that gets us. Oh, looking good. Yeah, I can find my intersection. So in 15.75 years, which will be about 3/4 of the way through 2005. So somewhere in the year 2005, Austin's population will reach 800,000 people.